Welcome to this explainer. Look, if you're a senior multi-cloud architect wrestling with a massive application ecosystem, you already know the absolute pain of keeping everything running smoothly. Today, we're diving straight into advanced API management and integration patterns on GCP. We're going to build a system together that is scalable, rock-solid secure, and highly efficient. I mean, think about it. How do you serve a mobile app, a web dashboard, and third-party partners without creating absolute architectural chaos? It's the classic spaghetti architecture trap. You start with a simple web app, right? Then you add iOS, then Android, and suddenly your partners are knocking, wanting direct access. Before you know it, you've got dozens of tightly coupled connections. And then boom, a single database update takes down a mobile app halfway across the world. And we all know that's usually followed by some very angry messages from the mobile dev team. So here's our top-down blueprint for today. 1. The multi-channel SaaS challenge. 2. Layer 1. Edge gateway. 3. Layer 2. Backend for frontend. 4. Layer 3. Internal microservices. 5. Global scale and monetization. And finally, 6. Core GCP design principles. Let's jump into part 1. The multi-channel SaaS challenge, scaling beyond the basics. To untangle that spaghetti architecture we just talked about, we absolutely must move away from point-to-point connections. Instead, we're implementing 3 distinct layers: an edge gateway, a backend for front-end layer, and internal microservices. By physically and logically separating these functions, we introduce some much-needed modularity. Basically, if the mobile team needs to push a change, they aren't stepping on the toes of the core backend team. Which brings us to part 2, Layer 1, Edge Gateway, the defense and routing layer. By using APG or API Gateway natively on GCP, you securely manage all your traffic before it ever even touches your internal networks. Think of this as your bouncer, your traffic cop, and your security checkpoint all rolled into one. APG inspects the incoming request, validates the credentials, strips out any malicious payloads, and routes it. It literally isolates your fragile internal network from the wild west of the public internet. Moving inward, we hit part 3, Layer 2, Backend for Frontend, our specialized diplomats. So the backend for frontend, or BFF. Here's the deal. Instead of forcing this bloated, one-size-fits-all API onto every single user, we deploy a unique BFF for mobile, a totally different one for web, and another one for B2B. Because let's face it, a mobile app running on a spotty 4G connection has vastly different needs than a fiber-connected web dashboard. This pattern ensures every client gets exactly the data it needs, formatted exactly how it needs it. For example, your mobile BFF is going to aggressively trim data payloads. It filters out unnecessary fields and minimizes size just to save bandwidth. Meanwhile, your web BFF is doing the heavy lifting, aggregating data from multiple sources to deliver bulky, rich data sets for those complex dashboards, all in a single call. And Apogee? It seamlessly routes the user to their specific BFF, optimizing performance without anyone having to touch the core backend code. Next up, part 4, Layer 3, Internal Microservices, the deep engine room. Down here, your ultimate goal is absolute decoupling. These internal microservices handle pure business logic, stuff like processing transactions or calculating subscription tiers. They honestly don't know what a mobile screen looks like, and frankly, they don't care. Hidden securely behind the edge and BFF layers, you can update them or, hey, completely rewrite them with literally zero client-facing downtime.
All right, part 5, global scale and monetization, enterprise-grade expansion.
Mapping your enterprise requirements directly to native GCP tools is where this architecture really pays off. We leverage Apogee policies integrated with Cloud IAM to verify identity right at the edge, not deep in your database. To protect your backends from sudden, massive traffic spikes, Apogee quotas strictly throttle those requests. And for monetization, the developer portal lets you actually package your APIs as products, turning your data pipeline into a legitimate revenue-generating SaaS product. Processing millions of API calls globally showcases the true power of multi-region deployment on GCP. By distributing your gateways and microservices across multiple regions, you're dramatically dropping latency to near zero for your end users. Plus, you're ensuring absolute high availability. If a regional outage actually occurs, GCP's global load balancing seamlessly reroutes the traffic. Your clients, they never even notice a blip. Finally, part 6, Core GCP Design Principles, the Architect's Framework. Let's synthesize this. Here is your foundational blueprint for a robust API ecosystem on GCP. Number 1, strictly decouple your layers. 2. Enforce security at the absolute edge via APG or API gateway. 3. Utilize dedicated BFFs tailored to specific client needs. 4. Design for multi-region scale right from day one. And 5. Centralize your authentication and rate limiting at the gateway to keep those internal services lightweight. Follow these, and you've basically built an enterprise-grade fortress. So your multi-channel ecosystem is built, and it's running flawlessly. But here's the real question. How will you evolve it when the next disruptive client type emerges? I mean, maybe it's AR glasses or some massive new IoT integration. Is your architecture flexible enough to just plug in a new BFF, securely route it, and keep running without having to rewrite your core engine? With this layered GCP approach, the answer is a resounding yes. Keep building, keep scaling, and I'll see you in the next explainer.